Okay, welcome back. This is 6.3, Integration by Parts, Part 2. Your objective for this lesson is still to integrate using integration by parts. Example 5. So we're going to evaluate e to the x cosine x dx. And we're still using integration by parts, so we still need to identify our u. Remember in the part 1, we looked at limit, which tells you which part of this you should identify as your u. So I don't have a logarithm or an inverse trig. I don't have a polynomial. So I'm going to use my exponential function for my u. So u equals e to the x, which leaves cosine x dx to be the dv. Du will be e to the x dx, and v will be sine x. And our formula, so the integral u dv equals uv minus integral v du. So I have sine x e to the x minus the integral sine x e to the x dx. Okay, well, I think I'm going to have to go again because this here still not what I'm looking for. So we're going to integrate integration by parts again. So in this integral, I use red. Still looking at limit. My first choice is still that exponential. So u equals e to the x, which means du is e to the x dx. dv is sine x dx. So v will be negative cosine x. Okay, so let's plug in what we have now. This front part stays the same. I'm going to say minus parentheses negative cosine x e to the x minus the integral negative cosine x, what's my du, e to the x dx. Gosh, okay. And again, we're going to kick this out here. So we have negative sine x e to the x plus cosine x e to the x. And that would be a plus, and then that one makes it a minus again. So minus, plus minus the integral cosine x e to the x dx. There we go. Okay. And you'll notice that this integral up top is the same as this integral right here. So let me rewrite this so you can see it, the whole equation. We have our integral e to the x cosine x dx equals sine x e to the x plus cosine x e to the x minus the integral, and I'll write it the same way, e to the x cosine x dx. And again, those are the same. So I'm going to do things a little bit differently. I'm going to actually add this integral to both sides. Because I think you can see it. This is just going to keep looping around. You know that sine x and cosine x do loop around. They are each other's integrals and derivatives. And e to the x is its own derivative forever. That's never going to change. So this is our only way to end the crazy cycle. Okay, so this is what we have right now. 2 times that integral that we started with equals sine x e to the x plus cosine x e to the x. And if I divide by 2, something magical happens. So now I have the integral by itself. Which is what I wanted in the first place. And on the other side of this equation, I have a value for the integral without an integral. Okay? So, this is my answer. You did have to use the fact that we had set up an equation and solve differently than before, but this way works, especially when you're caught in that cycle. So, remember this. Example 6. We're going to evaluate this function using tabular integration. Tabular integration is pretty awesome, I think, and you'll like it too. So this is something that you can use. Tabular integration is something you can use when one of these two functions will go to 0. So if you were to take the derivative over and over and over and you get a 0, you can use tabular integration. Basically, for a polynomial. So I'm going to say f of x and g of x. My f of x is x squared. My g of x is e to the x. And for f of x, in this column, I'm going to find derivatives. So this is my derivative column. Derivatives of x squared, well, 2x, and then the derivative of 2x is 2. Derivative of 2 is 0. This is what we want. Once you get to 0, stop. Over here, I'm not going to find derivatives. I'm going to find integrals. So I'm integrating e to the x. Well, what happens when I integrate e to the x? I get e to the x. When I do it again, I get e to the x. And again, I get e to the x. Now we're going to connect these diagonally down. So x squared gets paired with the second e to the x, 2x, and 2. And you stop when you get to that bottom of the list. So you shouldn't use the top right value or the bottom left value. Last thing that you need to do is label these plus or minus. So I'm going to do it alternating, always alternating, starting with a plus. Plus, minus, plus. And the value of this integral, so x squared e to the x dx equals, I need to multiply these. So x squared times e to the x is x squared e to the x. Once you multiply these two values, multiply by plus or minus 1, depending on what the line connecting them says. So here I multiply by 1, which doesn't change the value. My next line, I'm multiplying 2x and e to the x. So I get 2x e to the x. Then I multiply by negative 1, so I really have negative 2x e to the x. Last, multiplying 2 and e to the x, and I get 2e to the x. Multiply by 1, and that's just a plus 2e to the x. The last thing I need to remember to add here, because it's not in the column, is a plus c, because this is an indefinite integral. This is our answer. And you could actually go back and look, if you don't believe me that this works, if you take a look back from the previous video at example 4, because it is on the other video, we got the same exact answer for example 4 in the last video. Example 7, sorry. Example 7. Evaluate the integral x cubed sine x dx using tabular integration. So again, I see that x cubed, eventually its derivative will be 0. So that is my f of x. You want f of x to be whichever function will go to 0. We'll have a derivative that goes to 0, I should say. So we have f of x is x cubed, g of x is sine x. So my derivatives of x cubed, first I have 3x squared. Next in line, 6x, 6, and 0. Over here, the integral of sine x is negative cosine x. So looking at antiderivatives, basically. From here, I have negative sine x. From here, cosine x. From here, sine x. Now I'm going to connect them. And write plus, minus, plus, minus. So my integral x cubed sine x dx equals negative x cubed cosine x. So negative cosine x, x cubed gives me this. Plus tells me I'm not changing the sign. Then I should have negative 3x squared sine x, but that negative becomes a positive because I multiply by negative 1. Okay, plus 6x cosine x minus 6 sine x. The last thing I need to add to this extremely long integral is plus c. And I'm going to leave my answer just like that. I'm not even going to box it up because it is so long. Oh, and I think that is the end of part 2.